Okay, so chapter 3, power and scientific notation. What does 7 to the power of 4 mean? Shredik? Right, so 7 times 7 times 7 times 7 times 7. Now, which is greater, 3 to the power of 4 or 4 to the power of 3?
The power of 4.
Why?
3 to the power of 4 is 81. And 4 to the power of 3 is 6.
Right. Okay, so it is greater. And it depends on the number, all right? But 3 to the power of 4, because it's exponential, usually the bigger your exponent, the bigger it will get because it's exponentially bigger, right? So in this case, 8 to the power of 7 and 8 to the power of 6, how many times greater is it? It's 8 times, that's right. It's 8 times bigger, right? Because you're timesing it one more time. All right, so it's not at one time bigger. It's 8 times 8 times 8 times 8 times 8, so it's 8 times bigger. Okay. For these ones right here, can you actually add up the exponents? 4 squared plus 5 squared. Can you add up the exponents, Fion? No. You have to actually go back to like grade 4 math. Is that when you guys first did exponents? So long ago. Yeah. So this is just actually simply 16 plus 25, and then you add it, which is 41. Okay. This one right here, should I multiply first or exponent first? Exponent, because BEDMAS. So 3 to the power of 3, 3 times 3 times 3 gives you 27. 27 times 2 is 54. So then you get 54 minus 9, which gives you 45. Okay. This one, again, following BEDMAS, you're doing 5 times 3 to the power of 4, 81. 81 minus 2 to the 6. So 2 times, oh, by the way, on your calculator, you do have that exponent button, so you don't have to go like 2 times 2 times 2 times 2 times 2 times 2 like that. You could do 2. This is your exponent button, and then the 6. Okay, so you get 64. So on the calculator, sorry, in your calculation, you should do 81 minus 64, and then times it by 5. So equals 85. Okay. I'm not going to do every single one, but I'm doing these ones here because each one is an example of its own. Right here. Hey, what should I do first? So there are 2 different ways to do this question, but yeah, Shonik?
Is it exponent rules or not?
Not exponent rule yet.
Then that's 5 squared. Do that first, just 25.
Yep.
And 25 squared is 625.
Right. Okay, so this is a little tricky right here. Later on, yes, actually not later on, tomorrow. Tomorrow we will apply the exponent rule, but for now, you know that you do brackets first. So inside the bracket, 5 squared is 25, and then the square, so 625. Okay. We talked about negative exponents. So here, what does negative 2 in brackets square mean? Yeah.
We multiply negative 2 times negative.
Right, negative 2 times negative 2, which gives you positive 4. Good. Okay, so notice the difference between this and, oh, actually, no, not yet. I'm jumping ahead of myself. Okay, so negative 2 in brackets, Q. This will mean negative 2 times negative 2 times negative 2, which gives you negative 8. I heard 8. Negative 8. All right. Is it always that an even exponent gives you positive and odd exponent gives you negative. Okay, what's the condition? If the number itself is negative, then we take positive. Even exponent gives positive, odd exponent gives negative. But if the number itself is positive, right. Okay. So first, that number has to be a negative in order for like this rule to apply. And secondly, what does that negative have to be? In brackets. Perfect. So that negative number have to be in brackets. If it's not in bracket like this, then what does this mean if you were to write it out in full? If you were to write it in expanded form, what's negative 2 to the power of 4? Lexi? Negative 2 times 2 times 2. Excellent. So you see how this one, you're not timesing it by negative 2. You're just timesing, there's only one negative in the whole question. So this will actually give you negative 16. Okay? So this one, you can see the negative 2 is in brackets. So this means negative 2, whoops. I'm not going to have enough room. Okay, so this means negative 2 times negative 2 times negative 2 times negative 2, which gives you positive 16. Okay. Okay, so keep these four in mind. These four are the very important one to remember. So it's these four are the only like variations, basically. So these four are the important variations that you should pay attention to. Okay. So now that we understand more about exponent, we can get into scientific notations. Actually, not yet. Man, I keep jumping ahead of myself today. Okay, continue the pattern to fill each box. Use fraction to express values that are less than 1. So 10 to the power 4 means 10 times 10 times 10 times 10, which is 10,000. 10 times 10 to the power of 3 is 1,000 because it's 10 times 10 times 10, 10 times 10, 10 times 1. Sorry, just 10 basically. So this is 10. What is anything to the power of 0? 1. And then what is 10 to the negative 1? Not negative 10. Yeah. It's a decimal. What is the, but if I were to put it as a fraction? 1 over 10. Good. Okay. So notice my answer is positive. Negative exponents have nothing to do with the number being positive or negative. That's like the number one mistake that people do. Negative exponent does not make answer negative. Like no matter how many times I say it, somebody will still say their answer is negative because of the negative exponent. So like that's the number one mistake in this chapter. Okay? And what is that 10 to the negative 2? If you follow the pattern. Lexi? 1 over 100. Okay. Now, in terms of, so if we call this number our exponent, what do we call the 10? Anyone know the name? Phone? The base. That's right. Is our base always 10? No, it could be any number, just like these ones right here. So when we write it as a fraction right here, this would be 1 over 2, and this is 1 over 4. This 1 over 3, and this 1 over 9. Where did the 9 come from? Yep.
If you have x to the negative y, then that's just 1 over x to the y.
To the exponent, right? So the 9 came from 3 squared. If I were to write this out in proper form, this is actually 1 over 4 to the exponent 2. And then 1 square is just 1, and then 4 square is 16. That's how you get the fraction. So in proper format, that's how it should be written. All right. So your base rate, negative exponent does not make your answer negative. What it does is actually it flips your base. It flips the base. Okay. So instead of 4, it's 1 over 4. Instead of 3, it's 1 over 3. Okay. So here, these ones are pretty simple. I think you guys will be okay with it. Oh, here, let's just do, what is 0 to the power of 1? Yeah, 0. What is 1 to the power of 0? 1. What is 0 to the negative 1? What is 0 to the power of negative 1?
It's still 0? No, it's divided by 0.
It's undefined. That's right. It's undefined. Why it's undefined? Because 0, if I were to flip the base, because it's a negative exponent. So when I flip the base, it's 1 over 0 to the exponent 1. And 1, can you divide 1 by 0? No. So it's undefined. Okay. And the calculator will not lie to you either. If you try to do this on your calculator, 0 to the exponent negative 1, it will give you an error. So again, these 3 are ones that you should keep note of. Okay. Da, 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 da. So, okay. Okay. What about this one? So we talked about exponents in the second example right here. Okay, we talked about that, like the bigger the exponent, the exponentially bigger it is. But what about 6 to the negative 3 and 6 to the negative 4? Lexi? That's right. So 6 to the negative 3, because it's negative, I know I've flipped my base, so it's 1 over 6. And also, this is another format mistake that I always see. What's my exponent now? 3, positive 3. Once you flip the base, it's not negative 3 anymore. So it's actually 1, 6 to the exponent positive 3. And when you evaluate it, 1 times 1 times 1 is 1. 6 times 6 times 6, 216. And then this one, 6 to the power of negative 4 is 1 over 6 to the 4. So this gives you 1 over 6 times 6 times 6 times 6, 1,296. And because it's a fraction, this one is bigger. So because it's negative exponent, the smaller the exponent, the bigger the number. Okay, so now that we understand exponents, we can get into scientific notation. Okay, so for scientific notation, what is your base? Yep, 10. So for scientific notation, proper scientific notation, your base is always 10. Right? So this, if I were to write this out, it's 5 times 10 times 10 times 10 times 10. So my answer is 5, 1, 2, 3, 4, 50,000. The short way to do this is my decimal is after the 5. So times 10 to the 4 means I'm going to move my decimal place 1, 2, 3, 4 place over to the end here. Okay. But what about this? 10 to the negative 3. Which way should I move the decimal? Yep. Backwards or to the left? All right. And how many places should I move it? So originally it's 4. My decimal is here. So negative 3 tells me that I should move it 1, 2, 3 space to here. What do I put in these place values? Zeros. So this is 0.004. So answer becomes 0.004. Okay. And if you're thinking why, is because if you were to write it out, it's 4 times 1 over 10 times 1 over 10 times 1 over 10. I'll write it out. Times 1 over 10. Right? And you can see how each time your number is getting smaller. So from 4 to 0.4 to 0.04 to 0.004. Okay. Okay, let's just do an example of each of these questions and then I'm done. Okay, so for this one, 5.23 times 10 to the 7. How many zeros will I have here after I expand it out? Good. Shredik? I heard it. I heard you. So 5. 1, 2, 3, 4, 5, because you're moving that 7th place. Oh, sorry. Identify which of the following values are correctly expressed. My bad. I should read the question. Alright, which ones are properly expressed? This one, yes. This one, yes. Why is this not? Shmon?
That's be like a units place and there can't be 2 digits before the decimal.
Right, you put your decimal after one non-zero digit. So if I were to rewrite this properly, what would it be? Phil?
5.231 times 10 to the power of 1.
Perfect. Because I'm moving it one more space over, that means I have to add in one more digit to my exponent. Okay. Is this proper? Yes. All right. Yes, it is. As long as your decimal is after one non-zero digit, it's proper. Trailing zeros, it doesn't matter. And then this is also proper. You don't have to show that decimal. Okay, express each of the following as a power of 5. So what would this be? How would I rewrite this as an exponent of 5? Yep. 5 at negative 4. That's right. Right? Because of 5, you rewrite it as 1 over 5. So 1 over 5 times 1 over 5 times 1 over 5 times 1 over 5 is the same. Okay. And because it's a fraction, remember the negative exponent. Da, 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 da. Okay, I think you guys should be able to do the rest. Yeah, you should be able to do the rest. Finish up the rest. The back is more scientific notations. Okay, so yep, so that's the lesson. You answers for your homework is on page 5 and 6. So I would say homework for tonight up to page 4. Up to page 4. And then tomorrow we're going to take up page 4 as a recap. Okay. Uh, try these ones as well. I did go over that, but I wanted to see if you guys could do it. Okay. Yeah, and then tomorrow we get into the exponent laws on page 7. All right, so homework up to page 4. Homework up to page